All right, we are continuing on. If you are just coming back, we are on page 22. We got one more example before the guided practice that I want to go over with you. And this example says that Katie wants to divide her 30 flowers into two groups. So the ratio is 2 to 3. So what she did was she made a bar diagram to show the ratio of 2 to 3. And she's got 2 boxes on the top and 3 boxes on the bottom. And then over here they wrote the total of 30 flowers, which means in those 6 boxes, in those 5 boxes, the 2 here and the 3 here, 5 total. In those 5 boxes, they need to put 30 flowers within those boxes. Okay? So what they did was they took 30 and they divided it by the 5 boxes. So if you count by 5s, 5, 10, 15, 20, 25, 30, you would see that each box could take 6 flowers. Okay? So if she wanted to do a ratio of 2 to 3 with 30 flowers, she would have 12 in one group and 18 flowers in the other. All right? Which she could reduce, because if you take 12 out of 18, and what number could go into both of those? 6, right? And this will show you that you go down to 2/3, which is what the ratio is. What she wanted was 2/3. So that proves that you're right. So if you want to prove yourself, divide it down, and if you get the ratio that they started with, you know you've got the right answer. All right, moving down to our guided practice. Okay, it says, first of all, we're just going to review writing. Write a ratio as a fraction in simplest form. And it looks like we're doing pens to pencils. Now remember, if it's pens to pencils, you have to write it that way. Pens has to be listed first. So how many pens do we have? I'm counting 6. 6. How many pencils do you have? I'm counting 8. 8. All right, is that simplest form? Is that the lowest that we can go? No, because there is a number. Now 6 can't go into 8, but there is a number that can go into both of those, isn't there? 2. So if we divide them both by 2, 2 can go into 6 3 times, and 2 can go into 8 4 times. So our ratio is 3 to 4, or 3 to 4, or 3 to 4. Any of those answers is just fine. All right, pennies to dimes. Pennies has to be listed first because it's said first. We have how many pennies? 3 pennies. How many dimes? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 dimes. All right, smart people, can we reduce that number? 3 over 9. Can 3 go into 9? Of course it can. So let's divide by 3 and get that down to simplest form. Any number divided by itself is always 1. How many 3s can go into 9? If you have 9, how many 3s can you give away? 3 of them. So your ratios of pennies to dimes is 1, 2, 3. Look how crooked my board is. I don't know what's going on. 1, look at that. 2, just keeps writing sideways. 1 to 3. All right. Number 3. Did I have to go over a page? Yep. All right. Number 3. Last month, Ed ate 9 apples, 5 bananas, 4 peaches, 7 oranges. Find the ratio of bananas to the total. There's that total again. Bananas to total. All right. First, easy part, bananas. We got 5 bananas right here, 5 bananas. So we know it's going to be 5 over something. Now, the total includes the bananas. So you need to add 9 plus the 5 bananas plus 4 peaches plus 7 oranges. Add those up right now and see what you get. Let's see. Well, 9 plus 5 is 14, plus 4 more is 18, good, plus 7, and you get 25. All right, so 25 is our total. All right, we've got a 5 and a 25. We can reduce that down and simplify it. What can we simplify that down to? Remember, look at that numerator, see if it can go into the denominator first. And it can, so we're going to divide by 5. And we get 1, and 5 goes into 25, 5, 10, 15, 20, 25, 5 times. So your answer should be 1/5. For every 1 banana, there are 5 other pieces of fruit. All right, number 4 says, divide 28 cans of soda into 2 groups so the ratio is 3 to 4. 3 to 4. So I'm going to make 1, 2, 3 boxes on the top. 1, that was a horrible box. 2, 3, 4 on the bottom. 3 to 4. And our total cans, 28. So altogether we have 1, 2, 3, 4, 5, 6, 7 boxes. 28 cans has to be divided into 7 boxes. 28 divided by 7. Another way to think about it is how many 7s make 28. All right, 4. If you said 4, you got it correct. For each box is going to get a 4. 4, 8, 12, 16, 20, 24, 28. That adds up to 28, so you know you're right. Okay? So, in group 1, we would have 4, 8, 12. 12 in group 1. And 4, 8, 12, 16 in group 2. That would actually be your answer. All right? The ratio, if you want the ratio to be 3 to 4, you are going to end up with 12 cans in one group, 16 cans in another. All right, how can we use mental math to determine if a ratio is simplified? Well, if that fraction is in simplest form, the greatest common factor of the numerator and the denominator is 1. So, mental math to determine if the ratio is simplified. Simple enough. If the numerator is 1. If the numerator is 1. All right, right now I want you to take a moment. I want you to rate yourself on how confident you are about this ratio topic, okay? If you think that you are right on the money, you don't need help, you've got this down, I want you to put your bullet right here in the middle, bullseye, all right? If you're getting there, but you're still not quite sure, I want you to put your bullseye right around here. And if you really need some help, need me to pull you to the side and give you some extra work on this and extra practice with me, then I want you to put your bullet right next to that dart. All right, take just a minute, rate yourself, see how you're doing. Make sure you're honest with yourself. Some of these topics are going to be tough, and I want to make sure you have them down. So if you're not getting it right now, let me know. Come up and tell me, Spiracino, I'm not getting it. Okay? I'll sit down with you. We'll work it out. We'll figure it out together. All right? All right, this is going to be the end of today's lesson. When you get done, you're going to have some independent work to do on your own. I want to know that you've got this down before we move on to tomorrow's lesson. All right? So if you don't get that done, you're going to have to take it home for homework. So I want you to work hard, make great choices. Have a great day.